Hi everyone! Today we are going to be talking about domain and range, which means that we are going to be able to look at a graph of a function and identify both the domain and range. We are going to be writing the domain and range in two notation formats. We're going to use interval notation and also set builder notation. So let's get started. First, let's talk about just the domain of the function. The domain is the set of numbers that are in the x values, the input values of the function. Now, when we're talking about x values on a graph, that means we're looking at the x-axis. We're looking horizontally at the graph. So when we try to figure out the domain of a function, we're always going to read the graph horizontally, from the left to the right. There are going to be times when we have to deal with these arrows that happen at the ends on the left and right of the graph, and so we need to think about positive and negative infinity. As the graph approaches to the right, as we're moving right along the x-axis, if it keeps going that way forever, like this first one does, then that means that this end is going to approach positive infinity, because these x values on the x-axis are going to get really big. 1, 2, 3, 4, 5, 6, 7, 8, 100, 1,000, a million, a trillion. And if we look to the left on our graph, starting over on the far left, because this arrow here indicates that it goes infinitely in this direction, that means as I go on my x-axis to the left, I'm going to approach negative infinity because it's going infinitely small. -1, -2, -3, -100, -1,000, -1 trillion. So for domain, we're looking at how wide the graph is. How far to the left does it go? How far to the right does it go? And sometimes does it have any weird stuff starting and stopping in the middle? That we're not going to get into that too much today. All right, so when you look at this graph, you can see that it is a straight line and it goes infinitely to the left because it keeps going to the left forever, and it goes infinitely to the right because it keeps going in this direction to positive infinity forever. So if we wanted to write this as an inequality, we would write from left to right that it starts down at negative infinity, way off here somewhere. There's still a piece of this line here. And that negative infinity is going to be less than that x value, meaning that it could be anything down this direction. And on the right, it's going to be all the way up to positive infinity. So this is saying negative infinity is less than x is less than positive infinity. So the x values of this function are all somewhere in between negative infinity and positive infinity. This set of, for the domain, is also known as the set of all real numbers, because the domain, the x values, the inputs, could be any real number. In interval notation, we are going to use that negative infinity, comma, positive infinity, but we need to use some kind of bracket around this. Because you can't ever actually go and hit negative infinity because it always goes a little further, we're going to use a soft bracket, a parenthesis. And the same thing is true because positive infinity goes infinitely in that direction and you can't ever actually touch it. Then we're going to use a soft bracket or parenthesis there. So notice here that for the inequality or set builder notation, you have the value that we're looking at, the domain, so the x is in the center, and we're saying that they are somewhere in between negative infinity and positive infinity, but not equal to, because they're not actually touching it. In interval notation, we're saying the exact same thing, just in a different notation format. Our function goes from negative infinity all the way up to positive infinity, and we have soft brackets on both of those because it's never actually going to touch negative infinity, nor is it going to touch positive infinity. All right, so let's talk about this next one now. If we are reading the graph from left to right, we can see that we have this end point here, and that's at 1, 2, 3, 4, 5. So that means when we write this as an inequality, the smallest our function ever gets is where x is negative 5. And because it includes that negative 5, I'm going to say that negative 5 is less than or equal to x. Now, as we continue along this function on the right, and reading that graph, it keeps going forever, so it's going to go all the way off to positive infinity on the right. This one is not going to have an equal sign because it is not ever equal to positive infinity. Now, this one you could also write as x is greater than or equal, x is greater than or equal to negative 5. Because x is always bigger than or equal to that point negative 5. For every x value you pick on the x-axis, there's a point up here on this graph. For interval notation, we're going to take these two end values again. We're going to start at negative 5 and go all the way up to positive infinity. Positive infinity is something that can't be touched, so that's a soft bracket. There's no equal sign with that inequality. But this negative 5, notice that this was less than or equal to because that point, negative 5, is included on the graph. So instead of using this soft curved bracket, we're going to use a hard square bracket. This indicates that equal to part, meaning that negative 5 is included in the domain of the function. All right, so let's look at a couple more real quick. You'll see that we have a horizontal line here. The domain, if we are looking at an inequality, because we're looking at the left first to see where it goes forever to the left, so that is negative infinity is less than x because it goes infinitely down, and it goes infinitely to the positive direction, so that's less than positive infinity. You also could write all real numbers here. For the interval notation, I'm going from negative infinity to positive infinity, and I'm using soft brackets on both sides since it doesn't actually include the positive and negative infinity. All right, now this next one has something a little bit interesting going on. Do you see these dotted lines? They are called asymptotes, and they are a type of discontinuity or something that gets skipped or never touched in the graph. So if we're looking at the left-hand side of the graph first, you have this function that is going infinitely to the left. So it goes out to negative infinity. If you look at this side, it goes all the way out to positive infinity on our x's, but there's this dotted line at positive 2. That means that it doesn't ever actually touch that value positive 2. There's no ordered pair that has a 2 in the x value or input value spot. So if we look at this graph, you see how this line goes down forever. It gets really close to that negative or positive 2, so 1.9, 1.999, but it doesn't ever actually touch the 2. And the same thing is happening on this other side. This end of this branch is going up and getting really close to 2, but on the other side of 2, so 2.1, 2.0000001, but it never actually touches the ordered pair to something. So the domain for this one includes everything except for 2, because all of these x values have ordered pairs on the graph, and all of these x values have ordered pairs on the function. But this x is equal to 2 is not included, so we're going to say x is not equal to 2. When we write this in interval notation, it's going to be a little bit more complex because we have to say what's included, not what's not included. So the interval notation starts with this negative infinity that's included. It goes all the way up to this 2 value, but because it doesn't ever actually touch 2, we're going to use a soft bracket there because it doesn't include it. And then we're going to use a U, which means union, or it's a combination of this interval and another interval. This other interval for this branch up here starts at 2 on the right hand side of the 2 over here, and it keeps going to positive infinity. So in order to write the domain of this function in interval notation, you have to have both of these components, this branch's domain and this branch's domain. Let's look at range now. Range is very similar to domain, except we're looking bottom to top, down to up for range. We're looking vertically because we're looking at the y values. So we're looking at this y-axis and trying to see where it is the function is included or has a y value in the ordered pairs. We are again going to use positive infinity if it goes up infinitely and negative infinity if it goes down infinitely for this one. So let's look at our range first. Because we're looking at the bottom first, just like we look at the left first, this one is going down forever, so that means it starts at negative infinity. This time I'm going to write it's less than y because we're looking at the y-axis and the output values. And because it goes up forever, I'm going to say that it goes up to positive infinity. Remember, this is also all real numbers, so you could write it as the all real number sign as well, or symbol as well. For interval notation, you need to say that it starts down at negative infinity and it goes all the way up to positive infinity for the range. The range of the second one, we're looking from the bottom up to the top. So the lowest point is this point here. That's at 1, 2, 3, which means that the bottom of our range is from 3, and it goes up to positive infinity, including that 3. Oops, that should be a y. So we've got 3 is less than or equal to y is less than positive infinity. You could also say that y is just greater than or equal to 3 because it's bigger than. And for interval notation, I need to say that it goes from negative, or I'm sorry, not negative, it goes from positive 3, which is this point here, including it, and it goes up to positive infinity because this keeps going up on and on forever. Notice that whenever you use a less than or equal to sign, that's going to be a hard bracket in the interval notation. All right, so let's look at these next two. We've got that horizontal line again. For this one, if we're looking at the range, the y values for this entire function are always going to be at this 1, 2, 3 on the y-axis. So that means that the range is always, oops, I'm sorry. Yep, no, that's right. No, oh goodness, I'm making a mess. The graph is actually down here. Sorry about that. All right, so for this one, if this is the origin of our graph, we're looking down at 1 to negative 3. So that means the y values are always equal to negative 3. That means for interval notation, since 3 is the only y value that's ever included in this, that we need to have that negative 3, and we're going to put square brackets around that guy because the entire thing is all that negative 3. Now I'm going to go back to domain for a moment because I think I misread the graph on that one too. So let's flip back to the front. Yes, I did. Look at that. I picked the wrong horizontal line. So we are going to make some modifications here. We're talking about this line down here, not the x-axis. Silly me. All right, so let's look at, did that mistake that I made change the domain at all? Because it totally changed the range from positive 3 to negative 3. So if we're looking from left to right, because this is domain, out on the left, it's out at negative infinity, because it goes infinitely in this direction, and that's negative infinity. And so we've got this first piece right. It is starting out on the left at negative infinity. And then this graph goes and goes and goes all the way up forever to positive infinity, which means that this second piece is fine. So notice here that the domain did not change here because we were looking at a horizontal line. What did change was the orientation of this horizontal line on the y-axis. Here, when I was reading the graph correctly, it was down at negative 1, 2, 3, whereas before I thought this was my x-axis. I read it wrong, and so I thought this line was up at positive 3, but it was not. So the domain did not change with that mistake, but my range totally did with that mistake because finding your origin is super important. All right, so let's go to this last one now. When we are talking about range, remember we're looking down at the bottom, up at the top, but there is this asymptote in the center again that it's not ever actually touching. So this line here goes down forever to negative infinity, so that's where our graph is starting. And this one goes up to positive infinity, but it does not include this y is equal to 1. That's not there. So rather than writing negative infinity is less than y is less than positive infinity, because it isn't everything, it's not 1, you need to write for this one that y is not equal to 1. That means that it does equal everything that is not y is 1. All right, so now if we write that in interval notation, starting down at the bottom, we're looking at negative infinity. The graph is included all the way up to that point where we get 1. It doesn't include the 1, so that's a soft bracket. I'm going to draw the U to join together my pieces. Another soft bracket because it's going to pick up over here on the other side of the positive 1, not including it. And it goes up forever to positive infinity. All right, so with that information, you should now be okay with domain and range, figuring out the interval and also the inequality or set builder notation, which we're going to build on some as we move forward.